large number, that will lead to a large number. But, you know, think about the endpoint is 3 unit cells away. Right? 3 unit cells away if there's an endpoint there. But don't forget, if you draw, say for example, the simplest case, let's do from the origin to a point that is 3 unit cells away. Okay, so that end number could be very large. Could be, say for example, 5 or 6 or 4, or may not be 4, 3, how about that? Okay, so, but don't forget, when we talk about here, when we talk about the, the emergency part of this vector, we only consider the emergent part out of the basic unit cell. Right? Think about that. We do not use that endpoint. We draw a line from the origin to that point, but the real considering part is, say for example, from here to the very far away point. The only point we consider is here. Suppose that line intersects with this very basic unit cell at this point. We only consider that number. That number should be significantly smaller than 3. So you never get a large number than that. Okay. So you always get a number. So why not there?
So how about the small number? What if you wanted to go 1/10 of a unit in the x direction? At that point, you would immediately multiply by 10.
True, true.
And
yes.
10.
But don't forget. No. Don't forget that one.
Some other set.
Don't forget that one. When you consider that case, okay, we do not consider the endpoint as that. We consider the endpoint as this vector intersect with your basic set. That will be smaller. Think about that. That's my point. That will be smaller, right?
So how about from the origin to 1/10, 1, 1?
Yeah. 1/10, 1, 1. Okay. So 1/10, 1, 1 something around here, right? About there. Okay. Then what's the number? 1/10, 1, 1.
Do it on the board.
You have to get rid of the 1.
Yeah, you can't do like small numbers then. Right?
Food pot. Food pot. Okay, let me think about that one. Okay, let me think about that. That's a very good point. Yeah, if the number is 1/10, 1, 1, yeah, 10 multiplied by 10, you get 10, 1, 1. No, you get 1/10, 10. That's a good point. Okay. That's very rarely seen, this kind of. But anyhow, I will give you guys an answer after that. Okay. I need to think about that. Anyhow, we have about 5 minutes to finish here. Okay. Anyhow, this is the way to calculate the directional indices, and I want to briefly mention about the Miller indices, which is related to the vector. Okay. Vector indicate a direction, a line direction. The most important thing for the crystal, like the material science and engineering, is related to the Miller indices. Okay, Miller indices indicate the direction of a plane. Okay, so that means, see, for example, if we cut a plane out of the unit cell across the 3 diagonal points, that plane we know is 1, 1, 1 plane. Okay, so to the Miller indices, we use parentheses and 3 numbers, but don't forget, you do not have a comma in between. If you have a comma and parentheses, what that means? If you have a 1, 1, 1, what does that mean? Coordinates, right? That means this point. But now, if you do not have that one, the comma, we indicate the direction of this crystal plane. How do we determine the different crystal plane or the Miller indices? It's also straightforward. Also follow that one. Okay. So once again, you need to decide the x, y, z. The intercepts of the x, y, z with this plane. Okay. What the corresponding x and y, z? So for example, here. For this
no way of knowing.
plan that intersects with the axis at what point? At 1 point, right? So x equal to 1, y 1, z 1. So therefore, we can easily decide the x, y, z intercepts of the plan with the x and the y, z axis. If there's a fraction, once again, you multiply by some number, get a smallest, integers. We call those numbers HKL. Okay, remember here, HKL. This is very important later on. Okay, so the numbers you get finally. See, for example, if we get 1, 1, 1, the plan as I mentioned to you before, H equals to 1, K equal to 1, L equal to 1.
Can you do that? Can you just space them?
You can do that.
So that's the answer?
Yeah. I will tell I will tell you later.
I didn't know that.
Well,
I don't know if it's...
Okay, if there's no fraction, then everything becomes straightforward, right? If you have a negative number, put a bar above the number. See, for example, here, for this shaded line, it intersects the x-axis as 1. Y, there's no intersection. We use infinity there. Z, once again, not intersect. Infinity again. Take the reciprocal of these three numbers. Reciprocal of 1, you get 1. Reciprocal of infinity, you get 0. So therefore, the final one you get is 1, 0, 0. Remove the comma there and using the parentheses. That means this plan, Miller indices, is 1, 0, 0. Okay? Once again, if we have intercepts these numbers, okay, you can easily draw these kind of numbers, right? Because once you know the intercept, follow those intercepts, draw lines, then that will be the shaded area, will be the Miller plan corresponding to these intercepts. And then to decide what the Miller indices of this plan, once again, take the reciprocal of these intercepts, okay? If there's a fraction there, multiply by a number, 2, right? Multiply by 2. This one equals to 6, 3, 1, 2. Miller indices is this, right? Okay, once again, one more example. This plan, if I want you to plot 101 Miller indices plan, you know that the way to do that is take the reciprocal of this Miller plan. This is the reverse of the previous process, right? Reciprocal 1, 1, 0 reciprocal is, infinity 1 is 1, right? And then you can finally draw this plan because this plan intersects the x-axis of 1, z at 1, and not intersect with the y-axis. So therefore, this is the plan. And also, if I want you to do that, also straightforward, take the reciprocal of these three numbers, get that, and then get half, and 1. Get these three intersects join the plan, then that's it, right? So once again, if there's a negative number, that means when there's a bar above the number, you just put that as -1, right? And then take the reciprocal, you get that. When you get a reciprocal of 1 is infinity, that means there's no intercept. And then this indicates the plan that's corresponding to 1, 1 bar 0. But we shift the basic unit cell toward one number, move the unit cell to the left side of the plan, right? So by that means we will get this kind of Miller units. So, okay, anyhow, I want to finish here now. Next class, I want to finish the chapter 3, okay? I will assign homework tonight.